Welcome to the deep dive. Today, we are doing something pretty ambitious, I think. We're connecting two worlds that seem really far apart.
Definitely. On one hand, you've got the deep mathematics driving cutting edge AI.
Right, the silicon brain stuff.
Exactly. And on the other, a really profound human designed symbolic language, like deeply structured symbols.
And we're not just comparing them side by side, we're going deeper. The idea is that their shared structure, how they're built, actually points to a single unified way our minds work. A cognitive law.
It's quite a claim. We're looking at a study, it came out in November 2025. Christopher Boykin and his team. They took these structural similarities.
Between the AI method and the symbolic language.
Yes. And they didn't just stop at understanding intelligence. They actually used it to sketch out a whole lifelong model for education.
And that's exactly our mission for this deep dive. We want to pull out that blueprint for you, our listener.
Yeah, how does this unified cognitive law, this sort of informational physics, how does it apply across a whole life?
From a kid learning rhythm, say.
To someone much older, maybe in their 80s, making sense of a lifetime of experiences. It's kind of wild that the architecture of a machine,
Yeah, is potentially showing us something fundamental about human learning.
well, the core idea behind it all, the thing this study really hammers home, is simple but powerful. Order creates meaning.
Lose the structure, lose the meaning.
Pretty much. Think about a child clapping a beat, or, an engineer coding a neural net, even a poet choosing their meter.
They're all using structure.
Exactly. They're using structural awareness. The study argues this ability, perceiving and using patterns, is the key to getting knowledge.
Okay, so let's name the two systems we're focusing on. The AI side is...
Transformer Positional Encoding, TPE for short. It's become the standard, really, for how modern AI handles order in sequences.
And the human symbolic side.
That's the Alphabetical Matrix Frequency System, or AMFS. That sounds complex, but we'll break it down.
And the crucial point is, they both work using similar ideas.
Identical principles. The study claims periodicity, like waves, frequency, and mapping things into different dimensions, whether it's text for the AI or geometric shapes for the AMFS.
The goal is structured, meaning coherence.
That's the idea we're going to explore.
All right, let's dive into the tech first. Transformer Positional Encoding, TPE. Why was it even needed? What problem did it solve?
Right, so you have to remember what came before transformers. Models like RNNs, recurrent neural networks.
They read word by word, right, in order.
Exactly, sequentially, which is intuitive but slow. And they really struggled with long sentences or paragraphs, trying to connect the beginning to the end.
Okay.
Transformers changed the game. They introduced this self-attention mechanism.
Which lets the model look at all the words at once.
Yes, instantly. Every word can see its relationship to every other word simultaneously. Huge speed up, much better context.
But there's a catch, isn't there? That's where TPE comes in.
The big catch. Attention by itself doesn't care about the order of the words. It's indifferent to order.
So the lion ate the goat and the goat ate the lion.
Might look similar to the attention mechanism in terms of the words present and their raw connections. But the meaning is totally flipped.
Ah, okay. That's a huge problem for language.
A massive problem. So the AI needed a way to know the sequence, the order, without going back to that slow one word at a time processing.
And the solution was sinusoidal positional encoding, which sounds very mathematical.
It is pure math embodying that structural law. Basically, every word or token gets its semantic meaning vector, sure.
Yeah.
But it also gets an extra vector added to it, a positional vector.
Oh, yeah.
Fused together mathematically.
Yeah.
And this positional vector is calculated using these very specific sine and cosine functions, alternating waves.
Okay, waves. Like rhythm. How does that work? You mentioned position and dimension.
Right. The formula depends on two main things.
Okay.
Pose, that's just the word's number in the sequence. First word, second, third, etc.
Simple enough.
And that's which dimension you're looking at within that embedding vector. Remember, these vectors can have hundreds of dimensions.
Got it. So different dimensions get different waves.
Exactly. And here's the clever part. The dimensions are assigned different frequencies or wavelengths. Dimensions with a small I, like the first few dimensions.
Yeah.
They get high frequency waves, short wavelengths, they wiggle really fast.
And that's good for...
Encoding local position, like telling the difference between word 5 and word 7. Really fine-grained detail about neighbors.
Okay. And the dimensions with a large I, the later ones.
They get low frequency waves, really long wavelengths. They oscillate slowly across the whole sequence.
Ah, so they capture the big picture, the relationship between the start and the end.
Precisely. long-range dependencies, global context. So instead of just assigning a number like 1, 2, 3,
Which wouldn't work well if the sentence length changed.
exactly. Position 50 means something different in a short text versus a novel. But the cytic-assign approach gives the model multiple wavelengths of order information simultaneously.
It's learning local rhythm and global rhythm at the same time.
You got it. And why sine and cosine specifically? Because they're continuous, smooth,
Yeah.
periodic,
Unlike just counting 1, 2, 3.
which is discrete. It breaks.
Yeah.
But waves are continuous. The relationship between position 1 and position, say, 1,000 can be calculated smoothly, even if the model never saw a 1,000-word sentence in training.
That continuity is key for generalizing, for handling new stuff.
Absolutely essential. It lets the transformer sort of feel distance and closeness. Every word gets this unique, continuous rhythmic signature based on its place. It's the AI's internal timekeeper, its rhythm section.
Wow. Okay. That's elegant, actually. From pure math to sequence understanding.
It really is.
Now, let's completely shift gears from that computational logic to something that feels almost ancient, creative. The alphabetical matrix frequency system, AMFS.
It feels like a leap, doesn't it?
Yeah.
From linear algebra to symbolic design, but the study argues the underlying structure is, well, almost identical.
So what is this matrix?
Okay, imagine a system where every letter, every symbol or glyph is drawn inside a hollow circle.
Oh.
And the structure inside that circle is made up of combinations of just 3 basic geometric shapes: dots, lines, and triangles.
Dots, lines, triangles.
Got it. But here's the critical part. This isn't just random art. It's rooted in the physics of sound, acoustics,
How? How does geometry connect to sound?
through frequency. The study claims each of those geometric elements, dot, line, triangle, corresponds directly to a specific measurable frequency range within human hearing. Roughly 20 hertz to 20,000 hertz.
So a dot means a certain type of sound frequency?
Essentially, yes. It's multisensory translation. Sound becomes geometry, geometry becomes frequency.
Let's break down that geometric grammar then. What do the dots represent frequency-wise?
Dots mark discrete points of energy. Think sharp, quick sounds, a click, a high-frequency blip, a single drum hit, like a transient event in the sound wave.
Okay, sharp and quick. What about the lines?
Lines show relationship, directional flow, sustained energy. Think of a long, smooth line that suggests a continuous, stable tone, maybe a vowel sound or the underlying hum in something. Lower frequencies, often.
And the shape of the line matters, like curved versus straight.
Yes. The angle, the curvature that tells you about how the frequency is changing. A sharp curve might mean a quick pitch bend, a rapid modulation. A straight line suggests stability, a constant frequency.
Makes sense. And the triangles, that sounds like the most complex one.
Triangles are about synthesis, convergence. They visually represent multiple frequencies or lines coming together to form something new and coherent.
Like a chord in music.
Exactly like a chord.
Uh.
Or in language, maybe synthesizing different ideas into one concept. A triangle is the geometric sign for these things belong together, forming a new whole. It's a focused cluster of relationships.
So let me try to connect this back. TPE turns words into math vectors defined by sine waves.
Right, frequency in an abstract mathematical space.
And the AMFS turns sound and meaning into geometry defined by, well, literal acoustic frequencies and how they combine.
You've got it. It's this amazing blend. Art, acoustics, linguistics, all built on the same rule. Order, structure, gives rise to meaning through vibration, whether it's a mathematical vibration or an acoustic one.
Okay, I have to push back slightly here, or at least ask the question the study likely faced. This idea of shapes corresponding to universal sound frequencies, doesn't that sound a bit culturally specific? Like imposing a Western geometric view onto sound?
That's a really important point, and yes, the study addresses it directly. Their argument is that the AMFS isn't based on cultural symbolism of shapes, but on the physics of sound waves.
How so?
They base the connections on spectrographic analysis, visually representing sound frequencies. A dot corresponds to the visual representation of a transient peak. A line corresponds to a sustained fundamental frequency or overtone series. It's supposedly rooted in the quantifiable physical properties of sound itself.
So while the exact look of a glyph might have some stylistic choice,
The underlying principle that specific geometric arrangements map to specific frequency combinations is claimed to be based on objective acoustic reality. That's why it's useful for the comparison with TPE. It aims to capture a structural truth about sound, which they then argue mirrors the structural processing in the AI.
Got it. So it's aiming for physics, not just aesthetics or cultural convention. Makes the comparison much stronger if that holds.
That's the foundation they build on, yes.
Okay, this is where it gets really interesting. The study pulls these two seemingly different systems together and says, look, they're running on the same operating system. This is the core, the aha moment.
It really is. It's the convergence point.
Mm.
The study identifies 3 fundamental laws that they argue govern both TPE and the AMFS. It suggests that whether you're dealing with code or symbols, the rules for organizing information are the same.
Okay, law number 1.
Order emerges from frequency.
We touched on this, but let's nail it down.
In TPE, it's mathematical frequency. Sine and cosine waves encode position. The sequence is the rhythm of those abstract waves. In the AMFS, it's literal acoustic frequency. The symbol's structure is defined by sound frequencies and their harmonic relationships. Dot, line, triangle correspond to frequency patterns.
So in both cases, structure isn't arbitrary. It's vibration. It's frequency.
Exactly. Measurable vibration underlies order.
Okay, law number 2.
Continuity permits generalization. This is about why both systems can scale up, why they can handle novelty, things they weren't explicitly trained on.
Right, the TPE uses sine and cosine because they're continuous functions.
Precisely. Smooth waves. That means the AI can figure out the relationship between, say, position 100 and position 1000, even if it only saw shorter sequences during training. The math holds up across unseen distances because it's continuous.
And the AMFS, how is that continuous?
Because the sound spectrum itself is continuous, there aren't hard breaks between frequencies, right?
Yeah.
So the AMFS can, in theory, define new symbols for frequencies between existing ones, or even extend to represent ultrasound or infrasound frequencies, new harmonic tiers.
It's open-ended because sound itself is a continuum.
Exactly. Both systems have this inherent ability to grow and adapt because their foundation, mathematical waves or acoustic waves, is continuous, not broken into discrete, limited steps.
Makes sense. And the third law. This sounds like the big one for learning.
Law 3. Structure defines meaning. This is the pedagogical linchpin. Information only becomes meaningful when it's placed within a pattern, within relationships.
Okay, let's really go into the weeds here, comparing the mechanisms. How does TPE create meaning from structure?
Well, meaning in a transformer isn't just the dictionary definition of a word, that initial embedding. It emerges from the relational geometry created by the self-attention mechanism.
Relational geometry.
Yeah, think of it like this. The attention mechanism calculates how strongly each word vector attends to, or connects with, every other word vector. This creates a complex map, a sort of geometric pattern of relationships in this high-dimensional vector space. That pattern is the context, the meaning.
Okay, so it's the network of connections. Now, how does the AMFS geometry, specifically something like the triangle, act as an analog for that complex AI process?
Great question. Remember, the triangle in AMFS represents synthesis. 3 lines or frequencies converging into a harmonic whole.
Right.
The parallel mechanism in the transformer is actually a combination of 2 things. The multi-head attention mechanism, and then the context encoding step that follows.
Multi-head attention. Multiple perspective.
Exactly. The transformer doesn't just calculate one set of relationships. It has multiple attention heads, maybe 8, 12, or more. Each head looks at the sequence and computes relationships, potentially focusing on different aspects.
Like one head does grammar, another does sentiment.
Sort of, yeah. Or different types of connections. It generates multiple independent analyses of the relational landscape simultaneously.
Okay, so multiple relationship maps are generated.
And then, just like the triangle, visually synthesizes 3 inputs into one coherent shape.
The outputs from all those different attention heads get synthesized, mathematically combined, into a single enriched context vector for each word.
Precisely. The geometric triangle in AMFS is like a visible, symbolic representation of that abstract, multidimensional synthesis happening inside the AI.
Wow. So both systems are saying true understanding isn't just adding things up. It's about synthesizing relationships into a coherent structure.
That's the core parallel. Both demand synthesis for complex meaning.
This really reframes learning, doesn't it? It's not just about collecting facts anymore.
It shifts the focus to building awareness of structure, consciously seeing how relationships form knowledge.
And that's the goal they identify, training structural awareness.
That's the term they use, moving beyond just teaching coding or grammar or art history in isolation. Teaching the fundamental skill of seeing the underlying patterns, the rhythms, the structures that connect them all.
So someone with structural awareness could move easily between, say, analyzing code and appreciating poetry.
because they recognize the same principles of order, rhythm, and relationship at play. They see the shared cognitive law underneath.
Okay. If meaning is structure, then learning throughout life has to be about building and integrating more and more complex structures.
Which leads us right into their proposed educational model.
Right. This is where the study gets really practical. It takes that theoretical alignment and builds a whole educational framework around it. 3 stages, mapping structural awareness onto our lives.
Yeah, 3 distinct epochs, each with a different focus, a different cognitive priority. It starts with childhood, let's say ages 4 to 17, roughly.
And the priority for kids.
Sensory engagement. Experience first.
Yeah.
Think rhythm before you teach formal grammar.
Mm-hmm.
Color before abstract concepts. The whole epoch is about discovery through pattern.
Okay, makes sense for kids. How does the AMFS fit in here, the symbolic system?
It becomes what they call the sensory alphabet. The goal is harmonic literacy.
Harmonic literacy sounds musical. What does it mean in a classroom?
It means being able to perceive and use these structured frequency relationships in sound, yes, but also visually and physically. The curriculum they propose is very hands-on, multimodal.
Give me an example. How would a teacher use these glyphs?
Okay, so each AMFS glyph, the dot, line, triangle combinations inside the circle would be assigned not just its core meaning, but also a specific color, a specific musical tone, like a pure sine wave, and maybe even a specific physical movement or gesture.
Wow. Okay, so the letter A might be.
Represented by a glyph that corresponds to, say, 440 hertz, the note A. Maybe it glows blue in visuals, and the associated action is an upward open movement. Kids learn by singing the shapes, coloring the frequencies, moving the concepts.
Can you give a more specific learning exercise beyond just association?
Sure. The study describes using tuned sound chimes. Each chime matches the fundamental frequency of a key AMFS glyph, maybe the vowels. Children then use these color-coded chimes to literally speak or sound out simple words or short phrases. If cat involves a sharp C glyph, dot-like high-frequency beat, and a stable A glyph, line-like mid-frequency tone, and another sharp T beat.
The child has to sequence those sounds correctly. Beat, tone, beat.
Exactly. Using the right chime with the right duration and rhythm, they're physically manipulating frequency and sequence to make meaning. It's deeply sensory.
And the TPE side, the AI structure, how does that play in for kids? You can't teach them vector math.
No, you teach the concept of positional importance through what they call logical rhythm games. Simple stories, maybe on physical cards. Dog chased cat.
Okay.
Then they swap the cards. Cat chased dog. The meaning changes completely just by changing the order.
Right. Basic grammar.
But here's the TPE link. As they swap the physical cards, an animated sine wave is projected on a screen. Moving the dog card visibly changes the wave associated with that position.
Ah, so they directly see that changing position changes the rhythm, the wave pattern.
Exactly. They intuitively grasp that sequence is a measurable vibration, that order matters structurally, even before they know the math.
So the outcome for this whole childhood phase isn't just literacy or numeracy?
It's pattern recognition. A deep, intuitive feeling that all communication, all language, follows these invisible, rhythmic waves of order. That structure is everywhere.
Okay, foundational. Then we move into adulthood, ages, say, 18 to 59.
Right. And the cognitive priority shifts completely. It's no longer just discovery. It's about mastery and application.
The driving question becomes,
What can I build with this understanding of structure? It's the epoch of creation through structure.
so how does the AMFS evolve for adults? They're not just coloring shapes anymore.
Definitely not. The learning gets highly technical, but also creative. They move from reading the symbols to designing with them, analyzing frequency ratios, geometric compositions,
Designing what, though?
new systems. The study mentions an advanced course, symbolic ratio design, maybe designing a company logo. But the brief isn't just make it look good. It's design a logo using AMFS primitives, where the geometric relationships reflect a specific harmonic ratio, like 3.5, which acoustically suggests stability, perfect for, say, a bank.
Wow. So they're blending semiotics, music theory, visual design.
To express complex data or ideas in a way that is structurally resonant based on those frequency principles learned intuitively as kids.
The feeling becomes logic. And the TPE side for adults, now we get into the actual math.
Now you hit the formal computation. Algorithmic mastery. Learning the linear algebra, the vector spaces, how those sine waves actually function as memory cues in the code.
So implementing it.
Yes. Not just using off-the-shelf AI, but maybe building simplified transformers from scratch. Projects could involve creating a custom chatbot where you deliberately tweak the positional encoding. Maybe you change the frequencies to make you prioritize relationships between words that are far apart rather than close together, and see how that changes its output, experimenting with the structural rules themselves.
Okay, so the outcome for adulthood is applied synthesis.
Exactly. Taking that childhood pattern recognition and turning it into the architectural logic you use to build things, solve problems, create,
Sure.
demonstrating mastery of that unified cognitive law through action.
And finally, elderhood. Ages 60 plus. What's the focus here?
The priority shifts again, from creation outwards to integration inwards, understanding, seeing how all the patterns and structures built over lifetime fit together. The goal is reflection through resonance.
Resonance again.
Yeah.
How does the AMFS apply here? It sounds like it becomes quite personal.
Extremely. The study talks about using the glyphs almost as tools for cognitive therapy or meditation,
How?
by contemplating specific glyphs and their frequency geometries. For example, meditating on a symbol made only of long, straight, low-frequency lines might help externalize and structure feelings of calm or deep memory.
So the geometry provides an external anchor.
Exactly. If a memory feels chaotic or overwhelming, the act of drawing or even chanting a glyph representing order, like a stable triangle within a circle, could help align the internal state with that external symbolic structure. It's using visible order to process inner complexity.
That's quite profound. And the TPE connection for elders, is it still about math?
Less about math, more about metaphor. Using the AI's structure as a lens to understand human aging and memory.
How so?
You might explore how AI attention maps, the way the system highlights important words, resemble how our own minds focus on emotionally significant anchor memories.
Like mindfulness or selective recall.
Exactly. And the positional encodings, those waves marking sequence, they become a metaphor for the passage of time itself.
And maybe how memory doesn't always rely on strict sequence.
Precisely. The AI can retain the meaning, the relationships between concepts, the context, even if the exact order gets fuzzy. That mirrors how human memory often holds on to deep emotional resonance or core meaning, even when the precise chronological details fade.
So understanding the AI helps understand our own minds.
It becomes a tool for reflection. The elder learns that learning and life itself is rhythmic, cyclical. The outcome isn't just knowledge, it's reflective wisdom, seeing the whole symphony.
Discover, create, reflect, all underpinned by the same structural awareness. It's a compelling arc.
It really integrates the whole lifespan through this lens of structure and resonance.
Okay, let's get deeper into the mechanics. The study proposes a harmonic integration model with 4 cognitive layers. This sounds like where they really nail down the precise alignment between AMFS and TPE.
Yes, this is the detailed mapping. It argues that both human thought, when structured via AMFS, and AI processing via TPE, move through identical phases. 4 layers showing the structural equivalence.
Layer 1.
Perception, leading to pattern awareness.
Okay.
In the AMFS, this is the dot, the basic unit, the single frequency blip. In TPE, it's the initial token embedding, taking a word and turning it into a basic mathematical unit.
So recognizing the building blocks first.
Yes. Pedagogically, it's about teaching learners, kids or adults, to see the fundamental units before they start connecting them. Don't jump to conclusions, see the pieces.
Layer 2.
Leading to relational logic. Now we connect the pieces.
Makes sense.
The AMFS uses lines to show connection, flow, relationships between the dots or other shapes. TPE uses attention weights those scores, showing how strongly one token connects to another.
And the study draws a direct parallel between the geometry and the math here.
A very direct one. They propose that the properties of the line in AMFS, its length, its angle, its thickness, maybe should directly correspond to the numerical magnitude of the attention score in TPE.
Wow. So a short, steep line in a glyph.
Means a high attention score between 2 nearby words. A strong, immediate connection.
And a long, shallow, faint line.
Means a weak connection, maybe between words far apart in the sequence, a low attention score. It's suggesting the geometry is a visualization of the attention matrix.
That's more than analogy, it's claiming equivalence.
It's a bold claim of structural equivalence, yes. This layer is all about practicing linking ideas and evaluating the strength of those links.
Layer 3.
Integration, developing into structural reasoning. This is where synthesis happens.
The triangle in AMFS.
Right, unifying multiple lines or frequencies. And in TPE, as we discussed, it's the context encoding step, where the outputs from all those multi-head attention layers are combined into one rich, synthesized vector.
So the learner at this stage is practicing putting multiple pieces together, forming a coherent argument or a design.
Exactly. Synthesizing multiple relationships into a meaningful whole, moving beyond simple links to complex structures.
And the final layer, layer 4,
Reflection, leading to wisdom synthesis, seeing the biggest picture.
the AMFS uses the encompassing ring symbol for this.
Yes, the circle that contains the glyph, symbolizing wholeness, completion, the cyclical nature of things. In TPE, the analogous parts are the final, global context layers in the network. These layers look across the entire process sequence after all the local attention and integration to get a final, holistic understanding.
So this layer is about comprehending the whole system, the whole experience.
For the elder, yes, using the metaphors of the complete ring or the global AI view to interpret their life experience as a single, ordered, resonant composition.
Perception, relation, integration, reflection. Dot, line, triangle, ring, token, attention, context, global view. It's a very tight mapping.
It's designed to show the cognitive process is structurally identical, just manifested differently.
Okay, so the study doesn't just leave it at the model. It outlines specific curriculum details for 2 pathways, right? Symbolic and computational.
Yes, very practical.
Yeah.
Let's take the symbolic pathway first, the AMFS track. Sensory literacy. We talked about the singing and dancing the alphabet, but it gets specific. Vowels must be taught as sustained musical pitches, lines, consonants as sharp rhythmic beats, dots. Structured multimodal input is key.
Adulthood on the AMFS path.
Conceptual literacy. Moving to abstraction. How do combinations of primitives create new meanings? What happens if you put a triangle inside the ring versus outside? The challenge is to build personal symbolic alphabets.
Personal ones.
Yes, based on sophisticated harmonic ratios like the golden ratio, maybe to represent abstract concepts that are deeply meaningful to them, encoding personal philosophy structurally.
That's fascinating. And elderhood in the symbolic path.
Reflective literacy. It becomes philosophical, even therapeutic, examining how universal life patterns, conflict resolution, cycles are mirrored in the geometry of the glyphs. The peak exercise is resonant autobiography.
Writing your life story. Using the glyph.
Essentially, yes. Translating decades of experience into sequences of these structurally meaningful symbols, turning a life into resonant data.
Incredible. Now, the computational pathway, based on TPE, childhood.
Structural play. Physical games again. That floor mat idea representing the embedding space. Kids physically walk from one word mat to another.
And the sine wave changes on the wall.
Exactly. Their movement is the change in position, and they see its direct effect on the wave's rhythm. Internalizing position as vibration through embodied play. Cause and effect in sequence.
Adulthood in the TPE pathway.
Algorithmic mastery. Time for the real code. Formal instruction in vector math. Python libraries. They're not just users, they're builders. Experimenting by changing the frequencies in the positional encoding functions.
And seeing how that affects the AI's ability to remember long-range connections.
Precisely. They see directly how manipulating the mathematical structure changes the system's memory and understanding. Math becomes tangible consequence.
And elderhood on the computational side.
Cognitive reflection, using the tech as a mirror, studying intention weights where the AI focuses, and relating it to human mindfulness, focus, emotional salience, and memory.
Using tech to understand the self.
Right. Maybe using simple software to visualize how a small AI model processes a key personal memory, comparing the machine's focus points with their own subjective experience. Blending computational logic with deep introspection.
But the study stresses these aren't separate tracks forever, right? The goal is integration.
Absolutely crucial. The biggest push is for cross-generational collaboration projects, purposefully designed activities that force the different age groups with their different cognitive strengths to work together, fostering transgenerational intelligence.
How does that work? Each group brings something different.
Exactly. The projects are designed so each epoch's strength is needed. Take that sound-to-shape coding project example.
Okay.
The children, masters of sensory input and pattern discovery, create the raw material. They generate the initial sounds, the color associations, based on their intuitive harmonic literacy. They provide the creative spark, the input.
And the adults.
The adults, focused on creation through structure, take that raw input. They design and build the system. They write the code, the app, that translates the kids' sounds into the precise AMFS geometric symbols, maybe implementing specific frequency ratios. They are the architects.
And the elders.
The elders, masters of reflection and integration, receive the final output, the structured geometric imagery generated by the system. Their role is to interpret it. What emotional resonance does it have? what archetypal patterns emerge. They provide the wisdom, the meaning, completing the cycle.
Input, structure, meaning. Child, adult, elder. It's a closed loop.
A continuous cycle of learning and synthesis across generations. The Memory Resonance Archive project works the same way.
Everyone encodes memories as glyphs.
Yes, using their own level of understanding. Adults digitize these, maybe create visualizations showing the frequency patterns over time or across people. They structure the data.
And elders curate.
Elders curate. They look for recurring structural patterns in the glyph sequences across many memories. Maybe memories of loss consistently use glyphs with descending lines and dissonant dot clusters. They find the deep thematic resonances in the structured data, turning individual experience into shared patterned wisdom.
It validates the idea that even our lives follow these rhythmic structural patterns.
That's the profound implication, yes. Hashtag tag out outro.
So, when we pull back from all this detail, what this 2025 study is really proposing isn't just a neat comparison, it's a whole philosophy of learning, isn't it?
I mean, it really is. It's saying that learning itself is fundamentally a resonant phenomenon. It happens best when we engage with structured vibration, whether that's literal sound and geometry or abstract mathematical patterns.
The AMFS lets us feel that resonance through tangible symbols, the intuition, maybe the right brain.
You could say that. It taps into that immediate holistic pattern sense.
Well, TPE models it rigorously, computationally.
Yeah.
The analytical left brain.
That's a fair analogy. It provides the formal structure, the logic, and the key is uniting them, educating both sides of that cognitive coin.
So for a child, the takeaway is math isn't dry, it sings. Symbols aren't static, they vibrate.
Exactly. It connects those worlds early on. For an adult, it's about building things, technology, systems, art, that are consciously designed with this natural order in mind.
And for elders,
it's finding that ultimate harmony. Recognizing that all patterns in code, in nature, in a life lived, are part of one large, coherent composition. Finding the resonance in the whole journey.
This convergence, this unified view, the study argues it has some big implications beyond just schools.
Several major ones. First, it lends weight to something they call cognitive resonance theory.
Which is?
The idea that actively aligning our internal thinking rhythms with the structured rhythms of the information we're learning, well, it demonstrably boosts memory, creativity, even empathy. Structure isn't just for organizing. It actually enhances processing.
Okay. Second implication.
A potentially huge one for AI research. Symbolic computation. If the AMFS provides a visible grammar based on frequency, and TPE provides an invisible mathematical grammar for relationships, recognizing their deep structural equivalence reframes AI. As a branch of semiotics, the study of signs and symbols. AI isn't just math, it's a system for manipulating meaning through structure, just like language or the AMFS.
And that leads to?
Potentially, the Holy Grail. Interpretable AI. Explainable AI.
Moving past the black box where we don't know why the AI did what it did.
Exactly. If we can reliably map the transformer's internal logic, its attention patterns, its positional signals onto symbolic forms we can understand, like the AMFS geometries or related sound patterns, then we can finally see its reasoning. We can understand its structure, maybe even trust it more.
That would be revolutionary. And the final implication.
It's about our view of knowledge itself. This three-stage lifelong model, discover, create, reflect, strongly argues that knowledge isn't linear. It's not a race to a finish line.
It's cyclical, iterative.
Deeply cyclical and resonant. It aligns perfectly with developmental psychology, thinkers like Erikson or Montessori. The child finds the beat, the adult builds with the beat, the elder understands the whole song. You revisit the same structural principles at deeper levels throughout life.
It's about iterative integration, not just one-time mastery.
Precisely.
So the ultimate aim here isn't just better schools, but changing how we think about learning itself. Moving from like a factory model
to what the study beautifully calls a harmonic ecology of learning, a living system based on resonance and structure.
Which leaves us, and you, the listener, with a final thought to chew on.
As you think about this dual lens, the symbolic resonance of AMFS, the computational structure of TPE, what patterns in your own life could be seen differently?
Yeah, think about a habit you have that feels rhythmic, or a memory that keeps circling back cyclically, or even a big goal you've structured your work around.
Could you reimagine those as continuous sine waves, as intersecting lines and converging triangles within a larger circle, as frequencies?
How does seeing life, learning, creativity as a form of structured vibration change how you might approach something new? A new skill, a new project, even just reflecting on your day.
Maybe the secrets hidden in the deepest AI architectures are actually reflecting back to us some of the oldest, most intuitive truths about human wisdom and how we make meaning.
Something to resonate with. Thank you for joining us on the deep dive.